This machine is the first machine that will actually grade different types of produce on a consistent basis. So for example, one inspector might say that a certain package of strawberries is bad, another might say that they're good. This machine will make the exact same determination every single time.
Today, over 50% of all fruits and vegetables goes to waste because of the inefficient and inaccurate distribution. So, of 100 strawberries picked on the field, only 50 on average make it into the kitchen.
So the idea of inspecting groceries in an automated manner was born when machine learning and Amazon Fresh came together, and we were brainstorming ideas if we, for example, could predict the quality of groceries, if we can predict if something is turning bad soon, or also if we can make some statements about the taste, like if a strawberry is sweet or not.
The solution we came up with consists of an entire system with hardware and software, where the associates receiving fruits and vegetables in the warehouse will place the items on trays, and it will go through a set of cameras and sensors that, combined with machine learning techniques, will be able to decide whether the items are good to be sold or not.
Right now, my team and I are actually teaching the machine to go through and understand what is a good piece of fruit versus a bad piece of fruit.
One of the reasons why research in this area is so important is that in food, in fresh food, the quality plays a very essential role to the purchase decision.
This is only the beginning of the project, and the system will improve over time as we take more and more decisions and can integrate the feedback from our customers. And also, we want to expand the number of fruits and vegetables that we can inspect with the system.
Hello students, my name is Dr. Neeraj. Welcome back to my channel. Now today we are going to talk about machine learning in Python. So what I'm going to do is I'm going to write the program, and the program is about there's a database which is talking about various fruits like apple, orange, lemon, and some dimensions are given like height, weight, mass. Based on that, we have to classify these fruits. Now, what is the advantage of this? Is a supervised learning classification model, machine learning. What is the advantage of this particular software? How it can be used? This programming, as and when the volume is increased, it is difficult to segregate in, say, Super Shopee or somewhere where the fruits are mixed. Then with the dimensions, with the certain criterias, the data can be segregated. Now fruits are there. It can be a classification between, say, a good product and a bad quality product. The classification could be whether the customer will be loyal or not loyal. So this is an example. And the same program can be used for various classification problems. So now let us start with this programming. First of all, what I will do is this hash means a comment stating that what I'm going to do in this particular cell. The first is import the libraries Python. So what I'm going to write now is import pandas as PD. Then import numpy as MP. Then import matplotlib dot py plot as MP from sklearn dot selection import training train test let let's see if any error comes. Okay, there is right. So okay, now there is no error. Next step. Now what we're going to do, we are going to import the database. Import data file. df is any variable, it can be df, it can be file, whatever you want to write. df is equal to, we have already written pandas as pd, so we'll write pd dot read file equals to now where's our file? File will share. We'll go to properties and we'll copy this part. If you don't know, this is Jupyter Apps, Python. This is free. So what we have done, we have to just write down the part and then write down the file name. For the file name, file was this. So file name dot what? Dot txt, dot csv, dot exl, whatever it is. And now, one more issue is there. We have to write double times. Make it double. So error will come. Now let me see if error is coming. Invalid. Okay, because it should be in inverted commas. Again, enter. Yes. Read not 5. It should be read table. Hit enter. Now there is no error. Next step. Check out the data. Analyze the descriptive part. Descriptive. So first we will see the data. This is our data. As I told you, there are various fruits, apple, orange, lemon, and so on. And then there is fruit labels. For apple, it is 1. For mandarin, it is 2. Labeled. For orange, it is 3. Like this. Lemon, it is 4. So this is why we have done this, because whenever we are doing machine learning, we need numerical data, not categorical data. So it is labeled. Other things are mass, width, height, color. Based on these parameters, attributes, we are going to classify the fruit. So this is our data. Again, we can see df dot describe, enter. We can see that what are the total counts for all the columns, and what is the mean, what is the standard deviation. This is the quartile maximum, 45%, 50%, and all these things are there, descriptors. You can see standard deviation is below 2 for all except mass. Mass is more. Why? This is not, I won't say it is a outlier, because mass is going to be different for lemon, and for apple, obviously the weight, mass or weight will be different. That's why the deviation is so high, but it is normal. So I don't have to do anything in this. So all this we have seen. Next step. We define X and Y. So what is X and Y? For example, what is Y? Y is the dependent variable, and X is the independent variables which will be used to predict the Y. So Y in this case is what? Y is nothing but df data frame. Our file is being saved in df data frame. So it will be root underscore variable, and obviously commas, and then what will be X? Let us see what is X. Root underscore label is this, and what is X? X is mass, width, and height and color, independent variables. Control C for first. X is nothing but df and all these put it in the inverted commas, width, height, and color. And also it will be separated by commas. That's it. Shift enter. Now X and Y is defined. What else we have to do? Okay, now we are going to split the data. So let us split the data. The default is 75% and 45%. 35% will be the training data and 25% will be the test data. And what is training and test? Because when we are doing machine learning, we are going to fit the model by the training data. That is 75%. 25% of the data we will not show to the model, because when we are predicting, we want to give the model a data which it has never seen. It's like we cannot show the student the question paper in advance. So that is why 25% is kept separately, so that the model does not know what exactly is the data, and it will help us to find the model's accuracy and how well it generalizes the prediction. So we want to generalize it for the data which is coming from outside. And this 25% will be taken as an outside data for this model. I hope you understand this. Now, what we are going to do is we are going to make x underscore train, y underscore, x underscore test, y underscore train, and y underscore test. And we have already, for here, we have train test set from sklearn, which is a machine learning library Python. Is equal to train test split x and y random underscore state is equal to 0. This is not required for you to do, but because this is an educational video, I want everybody's result to be same. That's why I'm making it 0. It is like a seed. Always the result will be same. If you don't write this, every time it is going to take the samples randomly for making these, and then the result may be slightly different, and you may say that why my result is not coming. That's why for educational purpose we are writing this. Now because of this particular function, x train, x test, y train, y test has been formulated. You want to see x underscore train. Say it is not full data. It is only 75% random. 25% has been separated. So this is just to show you this is not required in this step. So let us go next. Now one more thing is, the problematic thing is that I want to normalize this data, because if you see this, these are the predicting IVs, mass, width, height, color. Color score is 0.55, mass is 192. The difference is too much. What I'm going to do is I'm going to scale these data into from 0 to 1. All this data will range only from 0 to 1. So that why I'm doing this, so that the prediction is not affected by such variations. So I'm standardizing or normalizing the data. How do I do this? But I'm not touching the prediction y variable. But sorry, the dependent variable, not prediction, dependent, predicted or dependent variable, I'm not touching. No need of normalizing. It's not required, mostly. So now next step is normalization of data from sklearn dot pre-processing my skill on pre-processing import email max scalar. I hope no error will come. Okay. Then scalar is equal to min. Let me copy a little bit. Copying is also good. It should not be copied. It should not be copied for practice. Because it is spinning. Okay. Scalar is equal to min max scalar. Okay. Now I have to scale. First thing which I want to scale is extreme. X, I'm going to save it in a variable always. X, then I will scale and put it in this, the scaled data. Extreme dot slash scalar equal to first, yeah, scalar dot fit underscore transform, and we have to write x underscore train. Enter. Next, x. We are not talking about x. Y. Not talking about y. Only x. X underscore test scalar equal to scalar dot transform. You may ask me why you are writing scalar dot transform and not fit. Explain, you wait. Now in the test data, I don't want this fit to be there, because fit means we are teaching the model something, but test data should not be taught. Told you, like it is like leaking the exam. So I have not done fit. Without fit, I'm just transcaling it. So this is what it is. Data is normalized. Now creating the model. So the model can be classifier models. It can be KNN, it can be logistic regression. So as per your model, you can create this. We are making KNN, K nearest neighbor classification. So from sklearn dot neighbors import K neighbors classifier. Let us see if there's any error. Okay. Okay, there should not be this. It's okay. Now we define it KNN equal to K neighbors classifier n underscore neighbors equal to 5. This is the k value. K neighbors is the k value of KNN. K times or kth neighbor. Number of neighbors, it will take 5. So what is this classifier? If I'm saying 5, it will see the nearest 5 points. The database is similar to this for what we are mentioning. Suppose I want to check whether this particular x is say apple. I want to see whether x is apple or lemon. So x will be checked by this model by seeing nearest 5 neighbors similar to these properties. So 5 is generally standard, 5 or 7. If the number is very high, it will be underfitting. If the number is very low, it will be overfitting of the model. What does that mean? Suppose I make it, where is our numbers? Okay, 59 is apple. Now suppose I make a segment which is 60, or not 60, 70. So 59 is total. That means another 20 is another 10 or 50. If I am making it 80 segment, another 20 is something other than apple. Because k value is so high. That is a wrong model then. It will not predict properly. And if the k value is very small, 1, it will make the model complex and noise will come. So it has to be average. K value should be average. Now, we have made our, we have created our model. Now we will fit the model with training data. Fit the model. KNN dot fit and we have to take x train and the scaled one obviously and y underscore train center has been formed. It has been fitted. Now we will see the accuracy of the model. We will test it for accuracy. Again, we will say a k and dot score, and we are going to test it on the test data, but first we will test it on the training for the sake of it, for showing you difference. So on training, x underscore rate underscore scale y underscore train shift enter. Okay. Oops. Accuracy of the, oh, I'm sorry. Ash, just a quick comment. Shift enter. Train scale. Scale is not defined. Train scale is defined. Train explain scalar. In scalar. It's not scale, it is scalar. Shift enter. Okay, now it is 0.95 the accuracy. But this is for training data. We need to do it with, actually we have to do it with what? With the test data. Again, we write the same thing. Root G. So of train data, we need to have test scalar and write test. So one is quite high. Now we are going to predict from our model. It is a comment. Now what I'm going to do is KNN dot predict. Okay. What we have to predict. Let us take one example of orange. Let me take this. Control C. Yes. Shift to the third. Work. Yeah. Working. 3 is what? 3 is what? 3 is orange. Orange is what we selected. Let us take some other one. I will try to, instead of number coming like this for orange, I want the orange to be seen, because for the customer it is easy for able to get the output. So what we will do is I make a dictionary. Dictionary means it is an editable form of data frame. So find in the number 5 the sort equal to we have to make a dictionary, editable form dictionary. What we can do is we can zip those two things, the label and the label and the name. We zip it together, and first one is df dot port underscore involved dot md. This is optional. And df dot dot underscore m dot unique means unique, not apple or many. Only one apple will be taken. Okay. We shift a comma. Maybe right. What is, we can see what is there in find with the fruit. So we have made this. Now we have to match these three pieces oranges. We have to match these two things. Now what we will do is, again, same command we have to use. KNN dot predict. Okay. We'll save this and think like red equal to KNN dot predict. This, and we don't need it here now. Control X it same thing here. And right prediction. The model. And then we press enter. Now if you see this, what this red has, it is printed. The same thing, orange. Now we have to match this with this 5. What I do is, I need to find the name equal to the file name, and we have to write this ERET, the result of this prediction. The result of this prediction is 3. We are putting it here, and 3 is nothing but orange. It will come in, it should come red, and we write 0. Yes. Then we print the name. Answer is orange. So this is how we have to predict. Now guys, one small thing, like if you increase the number, say KNN number, where is it? Classifier, where is the classifier? Yeah. If you increase it to say 50, see the accuracy. Yes. Okay. Sure. Let's do I make it say 30. And it has become 0.61, the training thing. What about in testing? It is reduced 0.33. Previously it was 1. So when the value of k is increased too much, is high, this model is underfitted. When the k value will increase, the boundaries, the regions will increase. Region will become bigger. So that is why the model is too simple to predict. It is not taking care of the variability. It has become more general in it. That is why it has reduced. Previously it was 1. The test. Training is not so important because that is not the correct prediction. Test has reduced. Similarly, if k is equal to 1, which is very less, it will be overfitting. Why overfitting? Because if k is equal to say 2, it will make regions with 2 points. So many regions will be there. The training data it will do well, but when we want to generalize for the outside data, the test data, the performance will be bad because regions are so many, and to fit it in that, there will be noise. The prediction will not be correct. So these are important things to understand about KNN. One more thing, what we can do, like what we can here is we can scale the input. So we are scaling the X and we are not scaling the input, and it may create mismatch. Be more accurate, more correct. It is advisable to scale the input also. So scaled but equal to scalar which we have defined previously. It will transform and we will put our input. So what is the input? If yeah, yeah, so then we have to performance. That now this scale input now what I will do is what is scaled got an array of numbers. These numbers they have been harmonized 0 to 1, which is the biggest number over here, first one. Tell me, but this is normalized. Now I will put this in the prediction matrix. Prediction KNN dot Reddit. On this thing, one is correct. Equal that it. Now this value should give one value name apple address. What I want is find those rules. Or do it's really and the print the apple has come. Now if you see my previous the one which I told you before, without normalization, without this scalar formation, some values may come wrong. We'll try it. But here it is now perfect. And suppose I reduce the mass to 50. And baby or this all the those tables 50. And then this will be confirmed that model is correct or not. But issue is sometimes prediction can be wrong, but not always. Putting the exit where the awareness can prevent 78.5 by 0.9. Not change, was right change on it. But not just one more time I will do it for my satisfaction. Order should be correct. Correctly take number. Now if lemon comes, model is and programming is correct. And I can win through. Thank you very much. Lemon has come and I'm happy that this thing is correct now. I will input a comment. If you want this file, I can mail it to you. Thank you very much for your time. Stay in touch and subscribe and bye.